Welcome to CE 402 Environmental Engineering 2 Module 5 Part 4. In this session, I am going to discuss about the design of Imhoff tank, a problem related to design of Imhoff tank. Let us move on to the problem, that is design an Imhoff tank to treat the sewage from a small town with 30,000 population. The rate of sewage may be assumed as 150 liters per head per day. Make suitable assumptions wherever needed. We have in the design of Imhoff dams, there are three parts, that is design of sedimentation chamber, digestion chamber, then gas vent. First one is design of sedimentation chamber. Then we can calculate the sewage discharge per day. The population is given 30,000 and the per capita sewage generation is also given, that is 150 liters per head per day. Then multiply these two values, we will get the sewage discharge per day, that is 4,500 meter cube per day. Then assume a detention period of 2 hours. This is already given in the design criteria. And the volume of sewage entering in 2 hours, we can calculate this, that is 150 into 30,000, that is the population, into detention time, that is 2, divided by 24. That is, we are converting the per day into per hour. So it is 375 meter cube. Assume an effective depth of 2.2 meter. Effective depth includes part of the bottom sloping walls of the chamber and a width of 4.3 meter. We are assuming a width of 4.3 meter for sedimentation tank and a effective depth of 2.2 for the sedimentation tank. Then we can calculate the length of the sedimentation tank, that is the capacity, that is the volume divided by area, surface area. That is 39.64 meter. Then we can accept a value of length as 40 meter. Then this is too large. That is in the design criteria, we know that the length should not exceed a limit of 30 meters. So here we obtained a length of 40 meters. So we can take two tank units, that is 20 meter, and with a width of 4.3 meter. So L by B ratio we can calculate, that is 20 by 4.3, that is equal to 4.65, which is in between 3 to 5. Hence, as per the design, the value is satisfactory. And then the discharge passing through each unit, that is single unit is 20 meter length, then 375 divided by 2, that is the half of the total discharge. The total discharges we already calculated as 4.5 mld per mld, and divided by 2 we will get the discharge passing through each unit, that is 2.25 mld. Then check for velocity. The length of the tank is equal to velocity into detention time. Length already calculated 20 meter. Then velocity into detention time is 2 into 60. That is, we converted it into minute. Then velocity in meter per minute is 20 divided by 2 into 60. That is 0.17 meter per minute, which is less than 0.3 meter per minute. Hence, the design is okay. Then check for surface loading. The surface loading is Q by BL. That is Q, it is given as 2.25 mld, that is 10 raised to 6. This is not 106, that is 10 raised to 6. 2.25 into 10 raised to 6 divided by 4.3 into 20. Here we get 26.162 liters, 26,162 liters per meter square per day, which is less than 30,000 liters per meter square per day, and therefore the design is okay. Hence, the dimension check, we have done the dimension check, then check for velocity, then check for surface loading. So, next we will move on to the dimension of the tank. Then the depth of the rectangular portion, that is the rectangular portion of the sedimentation chamber, and the sloping portion as shown in the figure, with an effective depth of 2.2 meter that we already assumed, with 4.3 meter width and bottom side slopes of 1 horizontal to 1.25 vertical, that we already learned from the design criteria and the figure and the sectional view of Imhoff tank previously shown in the previous slides. This height of the sloping bottom, that is x, height of the sloping bottom, that is the dotted line. We can calculate it from the slope given, that is 1:1.25 into 2.15. 2.15 means 4.3 divided by 2. That is total width is 4.3 and that is 4.3 divided by 2 into 1.25, and the depth of the conical portion is 2.69 meter. Now, with the effective depth of 2.2 meter, the height of the vertical portion below the liquid surface y is given by, that is the rectangular portion is given by 2.2 minus half into 2.69. That is 0.855, say 0.86 meter. This is the y portion, that is the rectangular portion. And adding a 0.45 meter freeboard, the total depth of the sedimentation chamber at the entrance of the slot will be 0.45 plus 0.86 plus 2.68, that is 4 meter. Then design of gas vent and the neutral zone. Here, neutral zone is 0.45 meter below the depth of 4 meter and above the digestion chamber. The tank is general is 20 meter length, but below this 4 meter depth, it shall be divided into number of compartments, say 4, each of length, that is 20 meter total length divided by 4 is equal to 5 meter. This you can see in the previous slide of section of Imhoff tank, that is figure B. The area of gas vent has now been provided on both sides of the sedimentation chamber. The width is adopted as 6.5 meter. That is the total width of the digestion chamber, including the sedimentation width, that is 4.3 meter. Then we will get and assuming a 15 centimeter thickness of the chamber walls, that is chamber wall thickness is 15 centimeter, then we get the air vent width will be 6.5 minus 4.3 minus 2 into 0.15 is equal to 1.9. If you have any doubt, please refer the figure C in the previous slide. This is about 1.9 divided by 6.5 into 100, that is equal to 29.23% of the total width, and therefore the design is okay. This should be in between 25 to 30% of the digestion area. Hence, 0.95 meter width of gas vent will be provided on either side of the sedimentation chamber. Then design of digestion chamber. Assume a capacity of the digestion chamber as 40 liters per capita. The capacity of the chamber is equal to population into per capita, that is into 40. Then we will get 12 into 10 raised to 6 liters, that is 1200 meter cube. Now consider four compartments. That is, four compartments are we assumed. That is for digestion tank, and units per tank. Per tank it is 4 units, total of 8 units with 6.5 meter width. The capacity of each unit or compartment is equal to 1200 is the sludge capacity, that is the digestion chamber capacity should be provided. So divided by number of units, that is total number of 8 units, then 1 unit capacity is 150 meter cube. Now assume the depth of each hopper as 2.1 meter, 2.1 meter hopper depth, and 1:1 as the side slope. Then the bottom uh, section dimension can be found out by 6.5 meter is the total width of the digestion chamber, and 2 into 2.1. 2 into 2.1 means the portion, the dotted line shown in the figure, you can see here, this is the 2.1 portion. That is this much part. And you can subtract this 2 into 2.1, that is 2.3 meter, and the other dimension, that is 5 meter. 5 meter means our width, that is 5 meter minus 2 into 2.1. Again, the slope is 1:1 and the depth is 2.1. Then we can calculate it as 2 into 2.1, that is 0.8. Then the bottom dimension will be 2.3 meter into 0.8 meter. Then capacity of each hopper. This can be calculated from the mathematical formula h by 3 into A1 plus A2 plus root of A1 A2. Here A1 is the total area, that is 6.5 into 5 meter, and A2 is the bottom section area, that is 2.3 into 0.8 meter, and the capacity of each hopper is 29.45. Then the balance capacity, the hopper capacity calculated at 29.45, the total capacity is 150 meter cube. Then we can calculate the balance capacity to be provided by rectangular portion of the section, that is 6.5 meter into 5 meter, that is 150 minus 29.45, that is 120.55 meter cube. Then height of this portion can be calculated, that is 120 divided by area of that section, that is equal to 3.71 meter. The total height of the digestion chamber including the neutral zone, that is 0.45, and 3.71 plus 2.1. This 0.45 is above the digestion tank depth. The total height, that is 6.26 meter. The total height of the tank from top to bottom, that is height of the sedimentation chamber plus height of the sludge chamber, that is 4 plus 6.25, that is 6.26, that is 10.26 meter. This height is within the practical limits, that is 9 to 10.5 meter, not 11 meter, 10.5 meter, and hence the design is okay. This is a complete design of Imhoff tank, a little lengthy. That is, design of sedimentation chamber is as normal as that of normal sedimentation chamber. A little confusion will be there in the case of this digestion chamber design. Please go through the design once more and do it yourself. Then only you can understand what the design is. So please go through. Thank you for listening. See you in the next class.